Hi there, Mrs. Bjornson's back. So on our third lesson of Chapter 3, we're going to learn a new way of factoring called factoring by grouping. Now before I get started, I have to prove something to you. And what I have to prove to you, I've done it algebraically here. I needed to show you that a minus b is the same as b minus a if we multiply that by a negative 1. So if that's a little bit confusing, this is all I mean here. I just wanted to show you that if I take 5 minus 3, that is the exact same as 3 minus 5, but I have to take the opposite of that. So let's just go ahead and show what this looks like. A negative and a negative is a positive, and indeed 2 is equal to 2. So we're going to need to use that for this lesson in the following examples. Now, did you go find your highlighter? I need you to get a highlighter if you don't. It's a critical part of today's lesson. Because what we're going to do is we're going to highlight the binomial that is the same in each red square bracket. And I've done the red square brackets for us already. So pause the video if you want to catch up right now and put your square brackets like I have on mine. I'm going to grab a highlighter, and this is pretty easy peasy. See, I have a 3y plus 2 and a 3y plus 2. That's all I want you to do. Just find what's the same. Okay, let's keep going. A minus 6. And an a minus 6. Isn't math easy? Well, it's fun. It's fun when it's easy. Now we have to hold the fort because I have an x minus 5 and a 5 minus x. And this is where using this little realization up here is going to come in handy. So let's go to the binomial that we want to flip around. And we can just go ahead and do that. But in exchange for switching those terms around, for the difference, a negative sign has to pop out. And what that negative sign does is when we have a negative times a positive, it's going to yield a negative there now. So now we have a minus 5 times that binomial. And I can get rid of this actually. Okay, and then I can go ahead and highlight. Boom and boom. Do you want to pause the video right now, and can you do the same thing that I did to C on D? Okay, hopefully you did this. Grab this, switch it around, a negative sign pops out, and that's going to, a negative times a negative yields a positive. Then I'm going to just get rid of that. Okay, and then I can highlight the same. Now, why, Miss Bjornson, why are we highlighting the same? Because when we are factoring out a binomial, this binomial is the same. We could say that it is common between the red brackets. And what do we do with all things common when we're factoring? All things common get to come to the front. So if I continue the next step for part A here, whatever's highlighted comes to the front. Now, what gets left behind? Just like in the last class, whatever isn't common gets left behind. So everything that isn't highlighted gets left behind in these other brackets. Now, of course, we want to simplify. So remember, the word simplify means make simple. So we want to make simple. If I have a 5y here and a 4y, I want to combine those into a 9y. And we are factored. Okay, let's do it again. Actually, you know what? I want you to do it again on B all by yourself. There's one little teeny tiny trick to B, but the first few steps are exactly the same. My hint to you is that when you bring your GCF of a minus 6 to the front, take a look inside of the two brackets that are left. There is something that you can do to one of them. Okay, so pause the video right now and go ahead and try B. Okay, let's see. Hopefully you got this first line here. But this is what's kind of different about this, is that my binomial, what was left behind, 3a minus 9, there was something common. There was a 3. And we want to bring all things common to the front. And so that, since it's a monomial, think of monomials as the little kids of the polynomial. The little kids get to come to the front. So we don't want to put the 3 in between the brackets. We want to bring it all the way to the front because it's a monomial. And so a minus 6 is fine. I didn't do any changes there. But now I just have an a minus 3 here. And expand. 3 times a is 3a. 3 times negative 3 is negative 9. So we're back to where we started. Okay. I'd like you to pause the video again and try C and D. Try both of them and see how you do. Okay, check your work. No surprises on C, but D, there was a common factor of 4 that I got to bring to the front, leaving behind 5x plus 1. So the key here is you bring your GCF, whatever the GCF that you have highlighted, that comes to the front every single time. Everything in yellow was the GCF. Everything in blue here, that was what was left behind. Okay, so that was what was left behind. In C, what was left behind? The 2, the negative 5, and that's what's left behind there. Okay, so I really like highlighters. That it just helps me figure things out. So yeah, go ahead, highlight away. Okay, so the blue is what was left behind and the yellow is what came to the front. Now, we gotta step this back now. If you can find yourself a pen lid or an eraser, something, this is mine. I made myself a little brick here. You can go get it right now. Because now we're gonna put this all together and actually do some, the final step to this factoring by grouping. So we're going to use this method when there are exactly 4 terms. So we have our 4 terms. We're going to grab our pen or our eraser for me, and we're actually going to put it over top of 2 of the 4 terms. Because what I want you to do here is I just want you to focus on the first 2 terms. So take a look at my steps. I like steps on the side. Step 1 is remove the GCF from the first 2 terms only. So in this situation, I just want to look at these first 2. And the only thing that's common here is an x. What's left behind is an x plus 3. Now we're going to take our pen lid or our eraser, whatever you had, and we're going to move it now to over here. And now what we're going to do is we're going to do the same thing, except we're only going to focus on the 6x and the 18. So the GCF here is plus 6. What's left behind? 3, not 3, x plus 3. I was getting ahead of myself. Now it's really important to know here that when you do it the second time, that the sign here is always the sign of the third term. Okay, so it's the third term that is going to determine what comes out, just the sign. So that just takes practice, and you'll get it eventually with a little bit of rehearsal. But now look at what happened here. Look at this. Common. What did we do on the last page? Anything that was common gets to come to the front. All right, that was the common bit. Now what isn't highlighted here gets left behind, and we are factored. You can check your work on these guys. Let me just remove my pen lid here. Come on. There we go. I'll get it ready on my second one over here. Perfect. You can check your answers with FOIL. First is x squared. Outer, 6x. Inner, 3x. Last, 18. and take a look. X squared, 3x, 3x, 6x, 18. We are good to go. So what I would like you to do now is to do B all by yourself. Don't do C though, because I'm going to do something different on C. I'm going to give you an alternative way to do C that you might like even better. Okay, so good luck with B, and let's see how you do. Okay, how did you do? I brought my GCF out, and I left behind the 2x plus 3. If you don't have the same binomials, you've made a mistake. It's not the question, it's you. So go back, check your GCFs. Once in a while, you can try switching around the middle terms if it's not working out, just to try something different. But yeah, it's a problem with something that you're doing with the GCF if these aren't exactly the same. Now, I was going to do an alternative method on C, but I think I'm going to do it on B instead. And then I'll let you choose what you want to do on C. So the alternative way to do these 4 termers is to do a reverse tic-tac-toe, where the F and the L must go kitty corner to each other from the center, and then it doesn't matter where you put the O and the I. And what do I mean by F, O, I, L? This is your F, O, I, and L. Those are your 4 terms. So what I'm going to do here is actually going to put in what those values are. So I'm going to put in an 8x squared minus 3, and then it doesn't matter what goes if we put the 12x or the negative 2x here. Now the beauty about this method is that you just have to, in every direction, here, here, and here, you're just going to be taking out GCFs. And whatever the GCF is, that's going to form your final answer. Okay, so let me just undo all these, and I'm just going to find the GCF. So what's the GCF on the first column? It's a 4 and an X. GCF on the second column, -1. Always take the sign of the term on the top. Okay, let's GCF the rows now. I've got a 2 and an X, and it looks like a +3. And looky, 4x minus 1, boom, 2x plus 3, boom. There will be a number of people that prefer the tic-tac-toe method. It is easier. There's fewer steps. So please, it doesn't matter to me which one you use. Just know one and know it well. Now, I'd like you to give part C an attempt all by yourself, and then check with me. That what makes C tricky is that there's a negative sign here. So we have to take out the negative sign on the when we do our second GCF. So let's see if you can do it right. Good luck. Okay, your answer is 3a minus 1, 2a minus 3. When you took out the -1, you have to flip the signs on both terms, and that's what people screw up on. And to know why, just bring the -1 back inside. -1 times 2a has to be -2a, and then -1 times -3 yields the +3. Again, you're gonna make a mistake. If you're gonna make a mistake, that's where it's gonna be. That's why we do our homework, so that we can practice and not make those mistakes when it counts on tests. Okay, I did the tic-tac-toe method down here if you prefer it. Yeah, if you're not, my best advice is if you're not getting the same terms coming out, try the tic-tac-toe method. Why not know both? Or if you're not getting the same terms coming out, try switching the middle terms around. Give that a go. Just try it again from a fresh start, and these things tend to work out, and they're really easy to check. We always check using FOIL. You've been foiled. Wah. Okay, good luck and happy mathing.